Hi, I'm Ahmed Daud, and today we are going to start machine learning module. Last time we have seen what is the underlying difference between artificial intelligence, machine learning, and the deep learning. And we also have seen about the data science. So in the last session, we have learned that machine learning is a subclass of artificial intelligence, which is used to, or the discipline works to make the machines to be able to learn from the data. Okay. So in this session, we will try to see the machine learning from some different angles. We will explore some different definitions, and we also will figure out where we can use machine learning and why we use machine learning. What are the different types of machine learning, and what are the challenges we face in machine learning? So first of all, machine learning. So machine learning is a science of program the computer so that computer can be able to learn from the data. If we will see from the other angle, we can say that instead of programming explicitly or explicitly writing the rules or the patterns, instead we can design such algorithm that can automatically detect the patterns from the data and can perform actions upon that. Okay. Let's suppose if we will design some program and we will hard code the patterns and the rules, then if the given algorithm or if we have to change or we have to modify something, then we have to change the code, or you can say we have to change the program. We have to remove some older rules, we have to add some newer ones. But instead, in machine learning, we design such algorithm that can automatically update the rules by the new data. So, more engineering oriented one is a computer program is set to learn from experience E with respect to some task T and some performance measure P if its performance on T, or let's suppose some specific task T, as measured by P improves with experience E. Then we can say that this program is set to learn. Okay. So by an example, let's suppose we have a spam filter. Spam filter is a machine learning program that can learn to flag spam, given examples of spam emails and examples of ham emails. Now, the examples that the system used to learn are called training set, and each example in the training set is called training instance. So in this case of spam filter, the task T is to flag spam for new emails. The experience E is the training data. The performance measure P can be defined because there can be multiple performance measures of by using these we can evaluate our model. So the performance measure P needs to be defined. For example, we can use the ratio of correctly classified emails. So here you can see as the experience is E is which is a training data. We are giving this training data to our model, and by learning from this experience, email spammer or spam filter is more prone to flag the spams for new emails. Okay. Now, why we use machine learning? Okay, so we will start from the traditional way, that what are the flaws and disadvantages of traditional programming techniques. Then we will jump how machine learning uh, change the way of thinking and make it you can say that it has uh, provided such as solutions that a traditional programming cannot do. So here, let's suppose you are designing a spam filter. First, you will see some emails that are spam emails, and you will find such words like for you, credit card, free, amazing, and you will see you will say that these are the frequent patterns and frequent words that the spammers are using in the spam emails. So you will write a detection algorithm for each of pattern, like if the email has for you or credit card or free or amazing or like these are four words. If there will be multiple words, of course, in real world there will be a lot of words, so you will write such number of rules, and if the new email will have these words or number out of these emails, these words, let's suppose there are four or five words that are matching with these words, with these patterns, then we can say this email is spam. So you are writing the rules for that, like if email has for you or credit card or free or amazing word, then this email is a spam. You are writing a rule. Okay, if then, or you can say if else statements. And in this way, you will test your program and repeat the test, the step one and step two. Again, you will find some frequent patterns and update your rules or detection algorithm until you will achieve some good results. So here you are manually writing the rules for the patterns. Okay, you are manually finding the patterns, which words are common in spam emails, like here these words, and you are writing the rules for these. So here, first you have studied the program, write the rules, then evaluate. If good, then launch. If not, then analyze error and repeat the process. So think in a way that there are if there will be hundred or thousands of words, okay, so you have to write hundred of thousand rules, or if in a simple way you can say you if you are doing coding, then you have to write thousands of lines of code to make an email filter. Okay, so for each pattern you are writing some rules. So this is not a trivial program, so you have to write a long list of complex rules. But on the other side, when we will see machine learning, so a spam filter based on machine learning techniques automatically learns which words and phrases. You don't have to specify that the word for you, credit card, amazing, if uh, present in some email, then this email will be uh, spam email. You just feed the data. Machine learning algorithm will learn by itself that which word and phrases are good predictors of spam, which phrases are repeating multiple times in the spam emails by detecting unusual frequent patterns of words in spam examples. The program will be much shorter, easier to maintain, and most likely and more accurate. Why it is most likely or more accurate, we will see. So let's go in this way. You will study the problem. Then, after studying the problem, you have figure out that what model should be work here. You will decide a model, and here you have a model, and you are just feeding your data. Okay, yeah, and then you will evaluate the solution. If good, then launch. If there is some bad accuracy, then you have to repeat the process. Now, in the traditional case, if the spammer notice that all the emails containing the for you word are blocked, they might start writing FORU instead. So in this case, if you are writing by using traditional program technique, then you have to update your rules, and instead of this for you for digit and you have to uh, make a additional rule, or you have to update your program by adding this rule. If the email will have for you this word for you, then this email should also be considered as a spam. Okay, so think in a way that if spammer keep working around your spam filter, he will updating the word or phrases in the spam emails. You will need to keep writing new rules forever. But on the other case, in the machine learning techniques, you just feed the data to the model. Model will model will uh, detect the phrases and patterns that are unusual in the spam emails, and it will figure out by itself without your intervention that these emails are containing these words. So these words are more common in the spam emails, so there is more chance that these words, the emails that have these words, then these emails should be a spam emails. So it will detect by itself. You don't have to manually write the rules again and again. So here you can see, if the spammer update the rules or update the phrases, you just feed the updated data to algorithm, and it will update its parameters upon these updated data, and you can uh, easily evaluate, or you can launch it in real time. So usually it is the whole process um, is working on a real time. New data is coming day by day, and ML algorithm or algorithms are updating their parameters continuously. So here, machine learning can also be used to mine the data. So now here you are not figuring out by yourself that which words are uh, causing, or which words are more common in the spam emails. You are just feeding the data to your model. Okay, now, and model will figure out which phrases or which words are unusual in the spam email as compared to the non-spam emails. So when you will feed the data to your model, and model will detect the patterns or unusual behavior in the spam emails, you can also study the phrases or the words that model has detected. Okay, so you have trained the model by giving the data. Model has given you some solution. You can inspect the solution, and you can see the patterns or phrases that model has detected, or model has figured out that these words are common in the spam emails. Okay, you can, instead of, like here, in the traditional technique, you are working on your data, and you are finding these patterns by yourself. If you are not doing that, and you are just feeding your data your model, when you feed your data to your model, and model detects some patterns and phrases, you can inspect these patterns and phrases, and you can use these patterns or phrases that are model detecting as some insights. Okay, and by in other words, you can say, by using ML techniques, you can also you can also get the insights from the data. You can also get the knowledge, or you can also mine the knowledge from the data. So that's why it can also use for the data mining. Okay, so that you are doing by yourself in the traditional technique, here the model is doing, and you can also inspect the solution. Okay, to summarize, uh, machine learning is better. So you don't need to write a long list of rules. If there it is good for the complex problems when you have to, in the traditional way, you have to uh, write a long list of rules, or there is no good solution is available at all. You can use machine learning. It will work better or much better uh, as compared to some traditional approach in the fluctuating environment, like in the case of spam filter. Spammer is continuously updating the phrases or words that uh, is using in their emails. So the environment is very fluctuating. So in that case, machine learning can adapt to new data, uh, you can say, very abruptly. So getting insight, ML can be used to get the insights from the data, like you have seen in the last slide. So where we can use machine learning, have you have seen this, like there are a lot of cases when we have complex rules, uh, and where the traditional approach will fail. You can use ML in a fluctuating environment, and here one important the aspect is that machine learning you can use, and machine learning has like a prerequisite that you should have enough data so that you can feed to the model, and model can learn from enough from the data. Okay, so data is like a fuel of model. Okay, so if you have enough data, then you can go for the machine learning. So what are the types of machine learning? There are four types: supervised, unsupervised, semi-supervised, and reinforcement. Okay, we will explore one by one each time. So supervised learning. From the word supervised learning, you got an idea that here the learning process is under some supervision. What will be a supervision here? Like here we have uh, given a label to each email, like this is the email dataset, and we have given a label to each email that this email is a spam, this is non-spam, this is non-spam, in this way. Now, if and our target is to find a label for the new emails. So there is some supervised learning. Okay, you have some labels for each of samples. Okay, there are two types of regression learning, supervised learning. Sorry. So one is when your target variable is continuous, and one is when your target variable is categorical. Like here, price of a house. Okay, price of house are the continuous values. There can be any price of the house. On the other hand, classification case, email is spam or not, there will be the target variable will have one and zeros only. Okay, there are just two labels. Like here, this example of regression. What is the temperature going to be tomorrow? So here you can see uh, the temperature will be a continuous value, and if you will say will it be cold or hot tomorrow, it is a categorical. Like if the tomorrow will be hot, then maybe it's equal to one, and if it is cold, then maybe it is equal to zero. So the trade-off between one and zero in the case of classification. So some of the most important supervised learning algorithms we will explore a lot. First, we will start from the regression techniques. Uh, so there are also a bunch of algorithms: k-nearest neighbor, linear regression, logistic regression for the classification. You will also see why regression uh, word is used with the logistic, as it is uh, used for the classification problems, support vector machines, decision tree and random forest, and neural networks. Unsupervised learning, as you can see from here, the word unsupervised, it is also clearing that the such type of learning that will be not under some supervision. Or in simple word, you can say that training data is unlabeled in that case. And the system tries to learn without a teacher. Let's suppose we have this training set and we are here using this clustering uh, unsupervised learning. Then when we feed this data set to the clustering algorithm, what it will do, it will uh, group the data sets, or you can say divide the data set into some groups on the base of some similarities. It plays similar samples into one group and other samples into another group. So clustering, anomaly detection and novelty detection, visualization and dimensionality detection, association rule learning. There are four different use cases or applications you can say you can use by using unsupervised learning. In case of clustering, let's say you have a blogs visitor website, okay, and you want to run the clustering algorithm on the visitors that visit your website. What the clustering algorithm will do, it will group the clusters of your customers on the basis of some similar properties. Like it, when you have specified that group, or you can say divide the your visitors of your blogs into four clusters, the algorithm will divide the whole data set into four clusters, and each cluster and the samples in each cluster will have some similar properties. Let's suppose, and you can also get insights from the cluster analysis. Let's suppose you have figure out that one cluster have a lot of samples as compared to other clusters. Then you can also analyze that this what are the similar properties and what are the characteristics in that cluster. Let's suppose the cluster that have a lot of samples as compared to other clusters. You can uh, do analysis on that, like uh, these type of customers are interested in sci-fi uh, blogs, and they usually see the blogs in the weekends, so you can design your blogs accordingly. In the same way, anomaly detection, novelty detection, it's also a type of clustering. When you run that type of algorithm on a data set, and you will find out a cluster that have very less number of samples, let's say one or two, or very least number of samples as compared to the whole data set. Then you can analyze that these samples are inconsistent with the rest of data, so there can be a chance that these are the outliers. You can use this technique for detecting unusual credit card transactions to prevent fraud, catching manufacturing defects, or automatically removing outliers from a dataset before feeding it to another algorithm. So there is another use case of unsupervised learning is visualization. You feed a lot of complex or unlabeled data to the model, and model will give you output of two-dimensional or three-dimensional plot accordingly. And another one, dimensionality reduction. It can be used if your dataset has a uh, is horizontally very you can say large and has a lot of features, and you want to compress your dimensions or decrease your number of dimensions, you can run this algorithm. Another application, association rule learning. It is actually associate some rules on the base of some other rules. Let's say you own a supermarket, and running an association rule on your sales log may reveal that people who purchase barbecue sauce and potato chips also tend to buy steak. Thus, you may want to place these items close to each other. Okay, it is associating that if the customer is interested in barbecue and potato chips, then the customer will tend to buy steaks. Okay, so to sell the steaks, you can place the steaks in near to these items. Okay. You are actually associating the rules. If the person is interested in that, then there is a chance that he is also interested in this also. Like if you are showing your interest on the Instagram in some mobile ads, then Instagram will also probably show you the ads of chargers and the cables and the pouches for the mobiles. Then and on the basis of association, that if you are interested in mobiles, then there is a chance that you are interested in the accessories of mobile. So all stuff is comes under the unsupervised learning. There is no label data here. So these are some of the famous algorithms like in clustering, k-means, db-scan, hierarchical. Normally these algorithms, one class SVM, dimensionality reduction. This PC is very important, and you will also see in later sessions also. Association rule learning, a prior algorithm, a CLAT algorithm. So here, image to clarify the difference between supervised and unsupervised learning. Here you can say a student is uh, learning from some teacher, but on the other side, a student is learning by himself or herself. So here the case is unsupervised without any supervision. A student is learning here. In the same way, there is another example, supervised learning and unsupervised learning. Here you are giving the input to the supervised model. Supervised model will classify that this sample is a apple or mango or pineapple. Okay. So on the other side, in case of unsupervised learning, if you are feeding the data to unsupervised model, it will not classify that this is apple or this is a banana, this is mango. Instead, it will because you have not labeled data during the training process, so it will just group the data on the basis of some properties. Like it will group these apples into one cluster on the basis of their red color, on the basis of their shape. So semi-supervised learning is another type of machine learning. In that, it is somewhere in between supervised and unsupervised learning. Here, the data is partially labeled training data, and there is a good example is Google Photos. Let's say you once you upload all your family photos to the Google Photos, it automatically recognizes that same person A shows in photo 1, 5, 11, and another person B shows in photo 2, 5, and 7. So this is unsupervised part of learning, that it is clustering the photos, okay, on the basis of some similar properties or similar faces. Okay, photo A, the person A has similar face, like on the basis of similar face in 1, 5, and 11 photo, it has clustered the person A. Now all the system needs for you just to give the name to these persons, just one label per person, and it is able to name everyone in every photo, which is quite useful for searching the photos. Here you can see you have a bunch of images, okay, and you will just give a name to one image, like this is an image of John. Now all the images where the John is present, it will automatically detect that this is the image of John, and it will give the name of John. Here, example of a simple partially labeled data. Like here, you can say some samples have labels and some samples have not labels. So these are unlabeled. So that's why comes under the unsupervised part. This labeled part will be comes under the supervised part, and the combination of both comes under the semi-supervised part. Now there is another reinforcement learning. Reinforcement learning is a machine learning process, but it is closely related to artificial intelligence. It has their working strategy, something different as compared to the last types, supervised, unsupervised, and semi-supervised. Here, the instead of model, like we usually call our learning system in the last types, a model. Okay, a model is learning, a model is under training, a model is testing. So here, instead of model, the learning system is agent. Okay, and the learning process carry out on the basis of rewards and penalties. I will give you idea of reinforcement learning by this example. Here, let's say you have environment, and here you are training your robot. So if this board will go towards the fire, it will get some penalty minus like 50 points. So next time it will avoid to go to the fire. It will move in another direction instead of fire. Okay. So in this way, on the base of penalty and reward, this agent will learn. Okay. So here the mechanism is something different. Like you create some environment, and here you specify some uh, movements as a penalty and some movements as a reward. And agent will learn by itself on the basis of penalty. It will avoid next time these stuff and or these movements. On the basis of reward, it will go in that direction. And the action and the best strategy, either I have to move in this direction or in this direction, as in right, let's say in the left direction is a fire, and in the right direction that is the to close the tap. So when it get the penalty, when the boat is moved towards the fire, it has learned that next time it will avoid the fire. So now it has designed the best strategy, which can be called a policy, to get most reward over time by going towards the side of the tap where it has to close the tap. Now, another good example of free reinforcement learning is AlphaGo program by Deep Minds. So it has also made the headline in May 2017 when it beat the world champion KG at the game of Go. It learned its winning policy by analyzing millions of games and then playing many games against itself. Okay, when it after the training process, now the learning part will be like a turned off, and then this program AlphaGo has played against the champion, and it also applied the policies that it has learned during that process of uh, learning. Okay, and it also like beat the KG. Okay, now the challenges that we usually face in machine learning. So this part we will cover in the next session. For now, uh, we have learned what exactly the machine learning, why it is important than the traditional programming techniques, and where we can use this machine learning, and what are the different types of machine learning. Okay, I hope you got enough idea about these questions, and hopefully in the next session we will see the challenges in the machine learning. So for now, thank you.